Lesson 79 is a two-part lesson. We have metric volume and 45, 45, 90 triangles. So metric volume is a little bit different. We're doing volume. You can either measure the volume if you had a cubic centimeter. So say I drew a cubic centimeter like this, and each side was one centimeter. This would be the same volume as 1 liter of liquid. So this is another conversion factor that you're going to have to memorize. It's another unit multiplier. 1 liter equals, that's this one actually. That's actually this one. Yeah. If I have a cubic centimeter, it's equal to 1 milliliter. So this would actually be 1 milliliter. If we had 1,000, a box that was 1,000 on each side, it would be equal to 1 liter. So let's keep that in mind. We're going to do a couple problems. The first one doesn't have anything to do with that. The first one says, example 1 says, use unit multipliers to convert 4,000 milliliters to liters. The unit conversion that we're going to use is, keep in mind that 1 liter is the same as 1,000 milliliters. You're going to have to memorize that as well. And you can see between 1 liter equals 1,000 centimeters or 1 cubic centimeter equals 1 milliliter. We're just basically dividing liters by 1,000 and getting milliliters. 1,000 centimeters cubed, we're dividing by 1,000 and getting 1 centimeter cubed. First one's really easy. We're going to convert 14,000 milliliters into liters. So we're going to use this unit multiplier. We want to cross out our milliliters, so I'm going to put milliliters down there. There's 1,000 milliliter in 1 liter. So the milliliters will cross out, 3 of the zeros will cross out, and so 14,000 milliliters equal to 14 liters. That one's not hard. The other ones are a little bit more complicated. This one says use unit multipliers to convert 4 cubic feet into liters. So we're going to go from a length measurement to a liquid measurement. So we're going to need to use, we're going into liters here, so we need to use that 1 liter is equal to 1,000 cubic centimeters. So that's what we're going to use. We're starting out with feet. So in order to go from feet, we have to go into metric, so we need to convert it into inches. So we're going to use 4. This is cubic feet written like this. First, we're going to convert them into inches. So we have a feet down here. We're going to need 3 feet. We have to go into inches because we have to go, in order to go from the English system into the metric system, we have to use inches into centimeters. You should know this. So we have 12 inches in 1 foot. We need 3 of them because we have 3 feet here, so we need 3 feet to cross out. I'm going to move down here. So we're going to convert, now we need to convert our inches into centimeter, and we're going to need 3 as well because we have 3 of these inches up here, so we need to have 3 inches down here. And, whoops, and we know that there are 2.54 centimeters in 1 inch. This is the way we go from our system of inches and feet into metric system, is through the good old centimeter and inch conversion. There we go. Now our inches are all going to cross out, and what we have is our cubic centimeters at the top. So we're converting into liters, so we're going to use 1,000 cubic centimeters in 1 liter. So this cubic centimeter crosses out all of these centimeters, and we have what we want. We went from feet cubed to liters. We just multiply this all out. 4 times 12 cubed times 2.54 cubed all over 1,000. And we get a final answer of, and the book does not even have it multiplied out. I'd prefer that you multiply it out. but they don't always have that multiplied out, and you just put liters because that's the only unit that's left. Let's try one more of these. Use unit multipliers to convert 4.7 liters to inches. So we're just going the other direction. So we're going to go liters to inches. So what we're going to do is we're going to go liters, and we're going to use the same unit multiplier. We're going to do 1,000 cubic centimeters in 1 liter. So we have liters. We're going to a length measurement. So we're going to use this multiplier right here. We're going to put the liter on the bottom, and we're going to get 1,000 cubic centimeters. We have to change it into inches now. This one's not quite as bad. We're going to need 3 centimeters. Oops, I lost my 0 there. So we're going to have centimeters, centimeters, and centimeters. There's 2.54 centimeters in 1 inch. 2.54 centimeters in 1 inch, and ditto, 2.54 centimeters in 1 inch. Our centimeters all cross out, and we get our final answer of 4.7. 4.7 times 1,000 in the numerator. In the denominator, we have 2.54 cube, and that's all going to be in inches cubed. So that's not too bad. The main thing is you have these new unit multipliers that you need to memorize. All right, let's do part 2 of the lesson. This one is 45, 45, 90 triangles, and we've already done the 30, 60, 90 triangles. These are a little bit easier. It depends on how well you learned your 36, 90 degree triangle. Now if we have a 45, 45, 90 triangle, since these angles are the same, the sides opposite them are the same. This is when it's 45, 45, 90 triangle, it's always an isosceles triangle. Every 45, 45, 90 triangle has the same ratio of sides. The sides are always in the ratio 1, 1, square root of 2. Every 45, 45, 90 triangle has the same ratio of sides. So, this is what an example looks like. It'll say, use similar triangles to find x and y. So what you want to do is line your triangles up so that they're facing the same way. I put my 90 degree angle to the left like that. And then you can do ratios. So anytime you have the 45, 45, 90 triangle, you need to memorize this triangle right here. It's 1, 1, square root of 2. So if we're going to do the ratio, we would do this one over this one. So it'd be 1 over x equals this one over this one. So it'd be the square root of 2 over 7. And then you can cross multiply. So you get 7 equals 2, square root of 2 times x. And then you would get 7 over the square root of 2. We divide both sides by the square root of 2 equals x. And remember, we can't have a square root in our denominator, so we have to rationalize. So, whoops, that should have been the square root of 2. Square root of 2. So we're going to get for a final answer, I kind of crammed everything all in here, 7 square root of 2 over 2. And that would be what x is equal. And the nice thing about the 45, 45, 90 triangles, these x and y, in this problem, x and y are both the same because they're both the sides opposite the 45 degree angle. This is one way to do these problems, is using ratios. There's another way we'll talk about maybe when we do the SAT. But for right now, you can just use the ratio between this triangle and whatever triangle is given. I want to try example 5 here is not really from your book, but this one's a 30, 60, 90 degree triangle. I just want to review that. If you have a generic 30, 60, 90 degree triangle, so mine all look the same. This is 30, this is 60, and this is your 90. A 30, 60, 90 degree triangle, the ratio of the sides are always 1 to the square root of 3. 1 is always opposite the 30, the hypotenuse is always 2, and the one opposite the 60 is the square root of 3, which is really 1 point something. So this side's the smallest, the one opposite the side the 30 is the smallest, the one opposite the 60 is the next smallest, the one opposite the 90 is the largest. So you want to line your triangles up so that they're facing the same direction like that, and then you just set up a ratio for these. So we would do y over 2 equals, and we don't really have a number there because I don't know where it went. Should be a 3. And that would be equal to 3. So you're going left to right, 3 over the square root of 3. So it's this over this equals this over this. And then you cross multiply, so you get the square root of 3y equals 6. Divide both sides by the square root of 3, so you get y equals 6 over the square root of 3. Then you rationalize, and you get 6 square root of 3 over 3. These aren't quite as easy as the 45, 45, 90 because the side opposite the 30 is not equal to the side opposite the 60. So you have to do 2 different problems with this one. So now we're going to do the x over 1. So you get x over 1 equals 3 over the square root of 3, and you do the same thing. You would get square root of 3x equals 3. Divide by the square root of 3, and you would get x equals 3 square root of 3, and then you rationalize. And for this one, you would get x equals 3 square root of 3 over 3. And I didn't simplify this one either. You should cross this out. So you're going to get y equals 2 square root of 3, and x equals the square root of 3, because these would cross out. I just threw that in there because I don't remember doing any of your homework problems like this, if you had questions on that. Okay, let's try one more. This is from today's lesson. This time you have a 45. They only give you one angle is 45, the other one 90, and you have to find the third, which if you have one is 45 and one is 90, then there's 45 left. So what you want to do when you hit these problems is first draw your kind of generic shape. This is our 1, 1, square root of 2. Every 45, 45, 90 triangle has the same ratio of sides. So this is the most basic version right here. So now you set up your ratio. You only have to do 1 because n and m are the same. So we go left to right. So we do 5 over the square root of 2 equals, let's do the n over 1. And this is n equals. So if we cross multiply, we get 5 equals, and we actually don't have to cross multiply here because it already says n equals 5 over the square root of 2. So rationalize. So you get 5 square root of 2 over 2 equals n. We'll talk about another way to do these, but in class maybe, but for now just use the ratio, the proportions. All right, that is it for lesson 79. Phew, I thought I didn't record it for a minute. I said shoot on the video. I'm like, shoot. Okay, so this is...
Oh, are you done down here after that?
Yep, I have to just put on YouTube. Algebra 2, lesson 79.